Good day, everyone. We are Group 1, and today we will be presenting our project titled Scalable Analysis of Global Hotel Supply. My name is Lei, and I'm joined by my team members, Rakib, Hamid, and also Brian. Next. So we are using a massive TBO dataset from Kaggle, which contains over 1 million hotel records. And the problem with this data is not only about the volume, but also about the variety, where it's a mix between like structured and unstructured data. Whereas the data was messy with critical information hidden in long unstructured text strings like hotel facilities. And based on that, the limitation for RDBMs is actually like traditional database struggles to actually process this kind of data, which contains like long string amenity fields, which leads to performance bottlenecks. And it also have a scalability issue where server-based solutions are costly and slow compared to distributed cloud systems when data grows. Next. Therefore, like we actually propose a solution that is away from rigid SQL servers and move on to the cloud data lake architecture as well. On the left, you see the traditional approach and the challenges that I have mentioned in the previous slides, while on the right, we show like our proposed solution and the reason that we choose the solutions, which contains like flexible ingestion, where decoupled storage that can handle any format, including like CSV and Parquet, effortlessly using like Google Cloud Storage, and also like high-speed processing using like BigQuery, which contains like serverless engines that enables rapid SQL explorations, and also like cost-effective scales using Spark, which enables distributed computing that manages massive data sets economically as well. And moving on, Rakib will walk you through exactly how we engineered this pipeline. Thank you.
Yeah, thank you, Ray. So I will first discuss about the data architecture of our project. So you can see our diagram, which is a decoupled storage compute model. Our pipeline, end-to-end pipeline, is simple and linear and logical. First, we downloaded the data from Kaggle and ingested into Google Cloud Storage data lake. In the ETL layer, we have used Apache Spark for data scraping, and we transform the data to Parquet. And then we have done feature engineering to extract the hotel amenities. Then we pass the process data both to Google Data Prop and Google BigQuery. And then we compare their performance. And at the end, we have created an interactive dashboard. In the data ingestion and scrubbing ETL layer, we first ingested the raw CSV to Google Cloud Storage. Then we have used Apache Spark for the data cleaning, like regex parsing, null filtering. At the data cleaning process, we removed around 5% of the data, which are incomplete and useless. And then we converted our data to Parquet format that gives us 95% of storage efficiency, which helps to downstream our queries much faster and cheaper. And finally, we write back the clean data to Google Cloud Storage. Now let's come to the feature engineering part, which is a crucial part in our pipeline. As you can see in the left side, we had a hotel amenities column of text type. It contained messy text like Wi-Fi, free parking, spacious conference, this unstructured text. And we use a Spark tokenization pipeline to decode this. We used regex to parse these text strings and generated a amenities dictionary. Finally, we extracted 46 high impact amenities, meaning converting unstructured text into structured text like Wi-Fi, parking, conference that machines can actually analyze. Now I will pass to Hamid for our implementation strategy.
Thank you, Rakib. So now I will go through the implementation strategy and evaluation. To empirically determine the optimal processing algorithm, we executed a parallel implementation using two distinct architectures as shown here. Left here the Dashboard Spark, and here the right PQ SQL. For the Spark implementation, we employ dynamic regex tokenization with a base Spark SQL to ensure precise multi-word matching to mitigate the computational overhead of this process. We utilize in-memory caching, creating persistent layer in RAM that optimizes subsequent iterative analysis. In construct, our BigQuery implementation leverages a serverless SQL architecture by utilizing regex-based joins. We achieve the same logical transformation with zero infrastructure overhead, effectively decoupling the analytical logic from cluster management. Next, please. For performance evaluation, our benchmark revealed a definitive disparity in processing efficiency. As is illustrated in this chart, the Spark cluster required 169 seconds to execute the Amenity extraction task. Conversely, BigQuery completed this identical operation in merely 4.6 seconds. This translates the to a significant 36-fold reduction in latency for analytical overload and workload. Consequently, while Spark remains robust for complex ETL pipeline, our data confirms that BigQuery is superior again for high-velocity analytical and aggregation. And that's all from my side. And now I will hand over to Brian.
Thank you, Hamid. Finally, after all the pre-processing and aggregation, we look at what the data actually reveals. The results are visualized using Looker Studio, where the geospatial analysis immediately shows a strong concentration of hotel supply rather than an even global spread. High-density clusters are clearly visible, particularly across North America and Western Europe, indicating significant spatial imbalance. The bar chart reinforces this pattern by ranking aggregated hotel counts, confirming that countries such as the United States, Italy, and Spain dominate in terms of total supply. Next. All of these insights are brought together in an interactive dashboard designed for exploration and comparison. The dashboard allows users to dynamically filter the data by dimensions such as city and star rating, enabling real-time segmentation without additional query execution. Through this interaction, we can clearly observe what we refer to as luxury differentiators. Amenities such as golf courses and conference centers appear roughly twice as often in 5-star hotels, while baseline amenities like free Wi-Fi remain common across all hotel categories. In conclusion, this project demonstrates how a scalable analytics setup can transform unstructured amenity data into clear, interpretable insights, and how BigQuery supports fast interactive analysis on large data sets. Thank you, and that's all for our presentation.